Hello, good evening friends. Today I am making a presentation on topic primary frequency services. This topic has already been covered by me in my earlier videos, but I'm again taking this topic because as per the new grid code 2023, which is being effective from 1st October 2023, certain modifications has been done with respect to this primary frequency services. So today I would be again taking up these changes and covering upon the part of primary frequency services. Now, the primary frequency control is basically the initial response of any generating station in respect to change in frequency. Normally, grid frequency is fixed at 50 Hz, but if there is a variation in the frequency change, then the machine has to pick up the load or decrease the load in order to give a margin for the or in order to or not give a margin, basically it acts as an immediate response in order to control the deviation in one particular direction of frequency. So the primary control is basically related to the inertia of the machine, and it is immediate and automatic control implemented through turbine governors and the frequency controllers. Now, this is basically a primary control of the frequency. The primary control shall be provided by the primary reserve ancillary services. The primary reserve ancillary services is maintained by the NLDC, that is National Load Dispatch Center. At any particular point of time, the NLDC ensures that the grid should have the minimum quantum of reserves available with it in order to avoid any contingency. That is, if there is a deviation in frequency from 50 Hz, then these reserves should come into play within 5 seconds and start contributing the grid so that the movement of frequency in one particular direction, that is either in the lower direction or in the upper direction, should stop, and thus these reserves will try to bring the uh, frequency back to the 50 Hz. Now, in order to fulfill this requirement, the generating stations should have electronically controlled governing systems or frequency controllers in accordance with the CA technical standards, and the generating stations should not be bounded by any limits, and they should be under the free governor mode of operation. So these are the basic requirements which the generating station should have in order to contribute to the grid whenever there is a contingency situation in grid. In addition to generating station, the NLDC will also identify certain energy storage system and demand resources to provide the PRAS support, and the NLDC will also compensate these energy storage system and demand supports in accordance with the ancillary service regulations. Secondly, the NLDC, the basically the first major change of these regulations is that the NLDC will now onwards publish a frequency response characteristic on all India level, and every generating stations or the PRAS provider should minimum achieve a a particular percentage of frequency response characteristic, and if the generating stations or the PRAS provider fail to achieve the minimum requirement of FRC, that is the frequency response characteristic, then they will be answerable to the grid. Now this FRC will be published by 15th of March for the next financial year, and all the generating stations should at least achieve a minimum level of, or at least cross the FRC which has been decided by the NLDC. Therefore, the PRAS provider should mandatorily own its governor or frequency controllers all the time, and based on the source of the fuel used, the CA has categorized the plant into four categories, and the performance of the generating station or the PRS provider shall be judged based on the which category that generating station or the RAS provider or the basically PRS provider lie. For example, if there are if you are talking about the thermal generating stations, then the droop setting will be fixed between 3% to 6%, and for hydro generating station it is between 0% to 10%. As we have been done with the PRAS and its features, now we will talk about certain other considerations which have been there in the regulation. Some of them have been already there and some have been newly introduced in the regulations. So let's begin. The first thing which the regulations say is that the wind solar sellers which have been commissioned after the CEA notified that now the renewables have also been made responsible in contributing towards the primary frequency response, either through energy storage system or through a common pooling energy storage system, or they are individually capable of controlling the frequency. They have to respond. Secondly, the nuclear stations and the hydro generating stations with pondage up to 3 hours or the run of the river project shall be exempt from mandatory primary response. This has been mainly done in order to avoid any security or safety risk to machines and the humans because of the sudden response of the nuclear plant or the hydro plant which have been mentioned. The 2023 grid code has also brought more objectivity in terms of the quantum of response required from the generating stations and the quantum of response which may be considered satisfactory for the grid in order to ensure that the generating station had responded to the primary frequency response required, or in case the primary frequency response triggered. As per the new regulations, that if a generating station generates 5% of the operating level load instantaneously within 5 seconds, and from 5 seconds to 45 seconds, and maintain this load for 5 minutes, then that response is considered satisfactory from the grid's point of view, subjected to a maximum of 105% of the MCR. Let me give an example on this. Suppose a unit is running at 400 megawatt and suddenly the frequency drops occurred, and the frequency dropped by 0.2 hertz. Let's take zero point 0.2 hertz from the 50 hertz, means the new frequency is 49.8 hertz and this drop is sudden. Then if a generating station which is running at 400 megawatt generates instantaneously 420 megawatt, that is a 20 megawatt step change, 5% step change, then that response is considered a satisfactory response in the eyes of the grid, and the generating stations will not be penalized for not showing any response or not showing the sufficient response in terms of any contingency in the grid. Also, the grid court has clearly stated that any generating station not complying with the above requirement shall be kept in operation only after clearing or only after obtaining the permission of the concerned RLDC. Means if any generating station doesn't show the response, then they have to take a permission from the RLDC that because of the such and such reason they cannot able to show the response, or they cannot show the response for a particular period of time. So they can be only allowed to operate only when the clearance is received from the RLDC. Other than that, a generating station or the wind seller, as mentioned in earlier table and the subclause G of these regulations, have the capability to reduce generation by 5% or 10% as applicable from the operating level, and subjected to the minimum of minimum turn down level, that is 55%, which means that in case the frequency rises by zero point 0.2 hertz, let's say the frequency goes from 50 hertz to 50.2 hertz, then a generating station which is running at 400 megawatt now has to reduce its output by 20 megawatt to consider a response, or to in order to show a response which is being considered satisfactory in the eyes of the grid. And this 5% response may help the grid in avoiding the contingency situations which may arise, and this response has to be come within the time duration of 45 seconds, and it has to be hold for 5 minutes. The document states that the governing action shall not be suppressed in any manner through load limiters or automatic turbine runner system or any turbine supervisory control or any coordinating control, and no time delay should be deliberately introduced. Also, in case of renewable energy generating unit, a reactive power limiter or a power factor controller or a voltage limiter shall not suppress this primary frequency response within its capabilities. If something is going out of your capability, then you may stop the response. But if everything is normal, there is no any deviation in parameters, then there should not be any deliberate mean to stop the unit from giving the response as required by the grid or as desired in the grid as per the table which have already been discussed. The inherent deadband in a generating station or the frequency controller shall not be exceed plus minus 0.03 hertz, which has been already there in the previous regulation. The next consideration is that the which has been already there in the previous regulation also, that the thermal and the hydrogenating units shall not resolve to valve wide open operation. That is, the governing valve should always be in some throttle position in order to generate the necessary response. They should never operate in a valve wide open, means they should not operate at a condition where no any sufficient margin is there with the boiler to give the necessary response. Secondly, the PRS, the primary response, as asked, should start immediately whenever the frequency deviates from the dead band, either in the negative direction or in the positive direction, and it should reach the full capacity within the 45 seconds and shall ensure that the necessary response for at least 5 minutes. Also, the new thing which has been introduced in this regulation is that RLDC will analyze each control area of its frequency response characteristic with a high resolution data of at least 1 second for regional entity generating stations, and for energy storage systems 10-second data will be monitored in order to ensure that whether the response which has been required has been sufficiently given by the generating stations or not. The concerned RLDC will also calculate the actual frequency response characteristics of all the control areas within its regions, and the performance of each control area in providing the necessary frequency response characteristic, which I will discuss in the next slide, shall be evaluated as per the annexure 2 of the grid code, and it should be also communicated to the generating station. The NLDC, in consultation with the RLDC, shall calculate the actual frequency response characteristic at national level by factoring in the frequency response characteristic of all the regions. Means the region will do its calculation, but of the different control areas, and on the basis of that calculation, the NLDC will analyze the whole region, that which region has given how much frequency response characteristic, and the NLDC will also monitor the FRC for the cross border areas also, and the NLDC will grade the performance of the generating stations based annually, and will be based on the 10 reportable events. In case the generating station whose frequency response performance is less than 0.75 as per the calculation which have been given in the annexure, the NLDC, RLDC and SLDC, as the case may be, after analyzing the frequency response performance, shall direct the concerned entities to take the corrective action. Means if the generating station or any storage system or any distribution provider who has been considered for providing the necessary primary response fail to get the frequency response performance of 0.575, will get a letter from the NLDC or from the SLDC, in whichever region it will come, for not performing to the level which has been required from them for providing the necessary primary frequency response, so which has been noted there in the earlier regulation. Now we will talk about the calculation of the frequency response performance. The frequency response performance will be calculated by the formula that is actual frequency response characteristic divided by frequency response obligation. Now, how will we will calculate this formula, or what are the values which will come? Suppose frequency dips by 0.2 Hz and the generating station is at 400 megawatt, the example which we have taken earlier. Now, as per the grid requirement, for any 0.03 Hz change of frequency, the response should start coming with a droop characteristic between 3% to 6%. Therefore, considering a droop characteristic of 4%, the generating station should generate at least 5% from the current operating level whenever the frequency drops by 0.09 Hz. In this case, the frequency had dropped by 0.2 Hz, but the response of 20 megawatt or the 5% of the operating level will be considered satisfactory. Therefore, the obligation is just of 20 megawatt, but the generating station is able to generate only 16 megawatt. Then the actual response would be 16 megawatt and the obligation would be 20 megawatt. The FRP will come as 0.8. Similarly, if the response shown by the generating station would be only 12 megawatt instead of 20 megawatt as required, then that station FRP will come as 0.6 and it will be graded in a below average. Similarly, if a generating station shows 18 megawatt response as in case of 20 megawatt response desired, the FRP would be 0.9. Therefore, it will be graded in an excellent category. So based on these grading categories, the stations will be categorized. So all these things which I have discussed with you have been introduced in the regulations, and this will comprises in totality of primary frequency response characteristic which has been desired by the grid, and what are the regulations which are governing this response. So I hope you got a good view of the all the regulations and good understanding of all the regulations. So this is all about. So let's end this video here only. I would like to say thank you for listening to my video, and if you like this video, please subscribe to my channel. Thank you and have a good night.